All right, today's notes are going to be on congruent triangles and graphing a line. So to review some of the ways that we can prove congruent triangles, we have this table here. The first one is the side postulate. And so you can use this way to prove triangles congruent when three pairs of corresponding sides are congruent. Then we have side angle side, and side angle side is when two pairs of corresponding sides and their including angles are congruent. That included angles word, that just is fancy for saying the angle in between the two sides that are given to us. Okay, so now we have angle side angle. You can use this to prove triangles congruent when two pairs of corresponding angles and their included sides are congruent. Once again, included sides is just fancy for saying the side between the two angles that we're given information for. Angle side is a reason you can use triangles congruent when two pairs of corresponding angles and the corresponding non-included sides are congruent. So non-included sides is fancy for saying the side not between the two angles that are given to you. Now, there is a fifth reason for proving triangles congruent, and this one is called the HL, otherwise known as the hypotenuse leg theorem. And so in order to use the hypotenuse leg theorem, you must have two right triangles and two pairs of corresponding legs are congruent and the hypotenuses are congruent. So an example or picture of what that would look like is when you have the right angles by that little square there, and then you have one pair of corresponding legs congruent, and then the hypotenuses are congruent. So here are some exercises that I can walk you through to determine if these triangles are congruent, and if they are, what reasons. Would it be the side angle side, angle side angle side, or the HL? It also tells us to be sure to mark any additional congruencies by vertical angles or the reflexive property. The reflexive property just talks about how and leg would be congruent to itself, or a side would be congruent to itself. Like in example 2, this side has the reflexive property because this side length would be congruent to itself because it's the same side. So we can say that these two triangles are congruent. We would say by the HL postulate because you know that it's a right angle, right triangle by the little square, and then because you have a pair of legs congruent, and then the hypotenuses are congruent. The hypotenuses are always across from that right angle. So that's how I know that it would be the HL postulate. So, all right, let's go back to number 1. If we take a look at number 1, we can prove that these two triangles are congruent. But first, you can't really see it until we put in the fact that vertical angles are congruent. So since we know vertical angles are always congruent, we can go ahead and add those tick marks to the figure. And now that we add those tick marks to the figure, we can say that these two triangles are congruent by the angle side theorem. Notice that in the name, the side is not between the angles, just like in the picture, the sides are not in between the two angles that were given to us. All right, so let's go to number 3. And so number 3, we have that reflexive property again, which means that TV is congruent or equal to itself. And so we can say that these two triangles now are congruent to each other because of angle side angle. Notice in the name, the side is in between the two angles. Just like in the picture, the side is in between the two angles that are given to us. Let's take a look at number 4. So with number 4, we know that all corresponding sides are equal to each other. So we can say these are congruent triangles by side. For number 5, we do know that they're right triangles, but we don't know anything about the hypotenuses. So we cannot use the HL postulate in this figure. But we only have 2 pieces of information, so we're going to have to go ahead and say that these are not congruent because we do not have enough information. We need at least 3 congruent parts, and we only have 2 congruent parts. For number 6, we know that these are right triangles, but once again, we don't know if the hypotenuses are congruent. But we do still have 3 pieces of information because both of these angles are right angles. That means they're both 90 degrees, which means that they're equal or congruent to each other. And so now we can prove these triangles are congruent by side, angle, side. Notice in the name, side, angle is in between the two sides, just like in the picture, the angle is in between the two sides. Number 7, we do need to add a piece of information here because we only have 2 congruent parts. But because we have vertical angles, we can always go in and prove or say that vertical angles are congruent because they are always congruent. And so now we can see a little bit more clear that we've got an angle, side postulate reason to prove why these are congruent to each other. For number 8, we have 2 sides and then an angle. Notice that this is SSA, or if you wrote it ASS, backwards, that would be a bad word. And then notice that SSA, if you look back at the directions, SSA is not one of our choices here. Now the HL postulate is similar to the ASS or SSA, but the thing about the HL postulate is that you have to know that they're right triangles, and we do not know if these are right triangles, and so we cannot say these are congruent because we don't know that. So we would say not congruent. For number 9, once again, we have those vertical angles, so we can add a little bit of information here. And now we see that we do have 3 pieces of congruent parts. We have an angle, and a side. Notice that the side is not in between the 2 angles, just like in the picture, the side is not in between the 2 angles. Number 10, we only have 2 pieces of information here, so we are going to go ahead and say that they're not congruent because there's not enough valid information for that, for any of our reasons. Same with number 11. We can add in those vertical angles, but at that point we still only have 2 congruent pairs of parts. So 11 would also be not congruent. For number 12, we have 2 pieces of information, but then we can go ahead and add tick marks for the length of MK because MK is congruent to itself because they share that side. So now we can say that these 2 triangles are congruent by the side, angle, side postulate. Notice that the A is in between the 2 sides, just like here, the angles in between the 2 sides. This angle's in between the 2 sides that are given to us. For number 13, this would be the HL postulate because we know that these are both right triangles. We've got a pair of congruent corresponding legs, and then we know the hypotenuses are congruent to each other. So the HL is what that is. 14, we can say that these are congruent by the angle, side, angle. And then 15, it looks like we don't have enough information, but BD should be congruent to itself because it is the same line. So we can say these 2 triangles are congruent by side, angle, side. Now these triangles look like they can be right triangles, but you should not assume right triangles unless they tell you. And so there's no square there to tell you that these are right triangles at the bottom. There's no square there, so I would not say that. So I would just use side, angle, side. I would not use the HL postulate for this one. All right, so now we're going to kind of switch gears, and I want to talk about linear equations because this is going to pop up on your test and on your quiz. That's coming up this week. So your next assignment is going to be a quiz assessment. I'm going to break the quiz apart, and I'm only going to give you like a review for the quiz on the first day, and then on the second day of that week, I'm going to give you like 2 problems from the quiz so that you're not doing too much. and you're still getting like a little bit of a review before you attempt that. So this is a little bit of a review from algebra. We want to solve for y, give the slope and the y-intercept of the line. Now a linear equation, when we write that form of a line, that is y equals mx plus b. So m is your slope and b is your y-intercept. It's also important to remember that slope is rise over run. How much you rise over how much you run. So the first thing that we want to do is we want to get this equation to look like that y equals mx plus b. So we need to get the y by itself. So the first thing we need to do is get rid of this x term. So to get the x term on the other side of the equation, we're going to subtract the 2x. So this will become 0. We're going to drop down the negative 6y equals, and then I like to write the x term first because in standard form, you notice at the top that the x term is first up there. Now notice that I dropped down this negative sign. I think that's a big mistake that most people make, is that they forget to drop down that negative sign, but we haven't done anything to it. It's still a -6, so it's important to carry that down. The next thing that we want to do is get the y by itself. So this says -6 times y, and the opposite of multiplying 6 or -6 is to divide by -6. Now the thing is when you multiply or divide on one side, you have to do it to every single term in the other side. So here this would be divide to 1. So we have y equals -2 over 6 can be reduced. Two negatives make a positive, and then 2 can go into 2 once, and then 2 can go into 6 3 times, and then we'll just bring down our x here. Plus 24 divided by a -6. Actually, it's going to be a negative number, so sorry, minus 4. And so now that we have y by itself, we solve for y, so that would be our equation here, 1/3 x minus 4. And then we need to pick out our slope. Our slope is the m value, and m is always in front of x. So slope includes x. Slope is in front of x. It does not include x. So our slope would be 1/3. Now remember, that's our rise over our run. We'll need that for the graph. And then the y-intercept is your b value, which we have as a -4. So this is our m, the slope, and then our y is our b value. Don't forget b for begin. And so that's where we want to begin graphing our problem. So when we graph a problem, we're going to want to begin where the y-intercept is a -4. So on the graph, we're going to want to plot where y is equal to a -4. So we're going to have to go down 4 units to make our first point. And then the m is also for move. So it's your slope, and your slope tells you how to move from your first point to get to the second point. So we are going to rise 1 and run 3. So if we rise 1, run 3, 1, 2, 3, it's going to look like that. Now your slope is positive, so it makes sense that my line is increasing here. I'm going to do that a couple more times. Rise 1 over 3, and then now we have your line. It's not the most straight line. Let's see if I can draw something a little bit better. There we go. So there would be your line, and that's how you would draw that. If you've got any questions or you feel like you need to slow the video down and rewind it, please go ahead and do so before you attempt the homework. I think it's also important that you try to finish this homework so I can give you feedback before your quiz assessment for the second day this week. All right, send me an email if you've got any more questions, okay? Have a good one, guys. Bye.